these are usually your directions to your problem, and I just want to pick those words apart a little bit. Evaluate. In math, when we talk about evaluate, that's just a synonym for solve or for simplify or to make it a little bit easier, but it's basically simplify.
Get the solution, find the answer.
The answer, the solution, it all means the same thing. So we know we're finding some sort of answer solution. The expression, that is a term that just means that there's no equal sign. Well, I was going to play the video. I forgot to play the song. I think I closed it down. I'll have to find it.
You can end with it.
Okay, I'll find it at the end. So an expression is a statement that just doesn't have an equal sign to it. Now, a given value, so a given value, a value is a number, so it's a number that the problem states. If it's given the problem, the problem gives it to you. The problem says what it is. So that's a given. The problem says what it is, and the value is a number. Of the variable is one of those letters. It's, a letter, and it can change. It has a value we're not sure of, or a value that can be changed under different circumstances. So we're going to be talking about that. So we're going to get an expression. They're going to tell us what the variable should be equal to in this case, and then we need to solve what that is. So let's start with an example. So we have an expression like 4x. We have an expression like 4x, and there's really nothing more we can tell you other than I have 4 sets of x, whatever x is. But your problem says to evaluate the expression when x is equal to 8. So now I'd like you to think about this as an if-then statement. So if, or when, or if this is equal to 8, what would 4x equal to? Then 4x equals what? So that's what we want to think. If x is equal to 8, then what would 4x be? So here are the steps we do. First thing we do is we write the expression. Did I tilt my board? I tilted the board so I could get here, and then I'm in the way. Expression. So the first thing you're going to do is write the expression. The second thing you'll do is substitute for the variable that you know. And then the third thing you do is you use the order of operations that we've been practicing always to solve. Operations to solve, to evaluate, to simplify, all of those words, we're going to use this order of operations to come down to a number. All right, so I have the expression. Now I need to substitute for x. So instead of 4, remember when the two numbers are put together, a number and a letter put together, it really means multiply. So instead of saying 4 times x, I'm going to say 4 times 8. Now it's really important that once I substituted for x, I don't write it as those two numbers smashed together, because I'm going to think, and everybody else will, that that's 48 and not 4 times 8. So if I am putting two numbers together, I can't use the smash rule. I really must put either that, or sometimes I could write it as 4 parentheses 8 if I wanted to. I really do need a little bit more information.
And that really is my favorite mistake. And somebody's already put that in the chat as an answer. And one of the reasons it is because students really understand that they're putting the 8 in for the x. So they understand the substitute. But what they didn't understand was that there's an operation there between the 4 and the 8. So that's very important to remember, that we're not just putting it in to create a digit, but that we are putting it in because we have to solve something, because there is a multiplication sign there. So it's not 48, because 48 would just be a digit, a number.
All right. This really means 4 sets of x. Whatever x is, I have 4 sets of them, or 4 times that many. So that's one of the problems. We could go a little bit more and we could have something like 3 times the quantity of n plus 1, and we really would say it this way, 3 times the quantity of n plus 1, and we want to evaluate that for n equals 5. So really when I'm thinking about this is another thing that can often confuse students. What does this mean? It means, again, just like I have the 3 here, but instead of 4 x's, which is what this means, I have an x, an x, an x, an x. I have 4 sets of x's here. What I really do is I have 3 sets of n plus 1. Whatever n is, soon we're going to say what it is if n is 5. But for right now, it's what n is. I have 3 of those. I have 3 of what's in here. Just like I had 4 of those, and this is just x in there. I don't know what is x or what n is. So I have 3 of n plus 1. So write the expression. I'm just thinking about what it means. I'm going to substitute for the variable. That's my next step. So I have 3, remember that means times the quantity of, that's how we say parentheses. N is 5 plus 1. So order of operations, parentheses first. So 3 times, and then 5 plus 1 is 6. 3 times 6 is 18. So if n is 5, then 3n plus 1 is 18. If n were something else, then 3n plus 1 would be something else. So I'm just evaluating it or solving this expression when I know when n is 5. It would be a different answer when n is a different number. Mrs. Nelson, did you want to add anything here?
What I always like to add here is that really this is the distributive property. So this could also be solved by putting the 3 on the n and then putting the 3 on the 1. So it would give me, if I were to distribute that, I would have 3n plus I would have 3n plus 3. So that equals 3n plus 3. Yes, like that. And so then if I substitute, which is the next step, in for the n, that would give me 3 times 5, which is 15, plus 3, which would still give me 18.
So either way you do it, whether you're thinking it as 3 sets of this, I'm going to figure out what the set is and then multiply by 3. I'm going to figure out that this problem figures out what's in the set and then multiply by 3. Or you can say I have 3 n's and 3 1's. If we look at it here, how many n's do we have? 3 n's. And how many 1's do we have? 1, 2, 3. So equivalent expressions.
So you solved the parentheses, but I eliminated the parentheses and then solved using multiplication and addition left to right. Either way is an okay way to do it.
Either way, okay.
Yeah, and lots of times they show us that distributive property in ways that they ask us to look at two expressions by putting an equal sign between them and seeing if they are equivalent.
So just think about if 3n plus 1 is that the same as 3n plus 3.
We can't see that.
Can't see that? Okay, so I gotta go that way then.
Now we can, yeah.
So what I like to do is just draw a little line here, which I don't mean that that means it's unequal. It means that I just want to look at this side and then this side. We'll do that the same way. You'd write the expression, which we did. And we're just trying to see if these two are equivalent expressions, then if I put a value of n in, I should get the same answer both sides. So let's see if it's equivalent.
Let's use 1 this time because it'll be an easier problem.
Okay, so let's check it if n equals 1. So if n equals 1, what I get here, I'm going to substitute for n. So I'm going to put 1 there and 1 here. So this would be 3 times 2. 3 times 2 is 6. Now I want to do the same thing on this side. I'm going to bring this line down here. I do the same thing on this side. So 3, this time times 1 plus 3. So 3 times 1 is 3, plus 3 more, and 3 plus 3 is 6. And since it gave the same answer, when n equals 1, those are equivalent expressions. If it was the same for everything, which we know it will be, then they are always equivalent. So
Yes.
something we'll be checking coming soon, but it would follow the same pattern, writing the expression, substituting for a variable, and using always that order of operations to solve.
That'd be a great I wonder question. I wonder if it's equivalent for one number, does that mean it's equivalent for all numbers?
Sometimes I would say that if you had to check it, I would always check for a negative, because if it wasn't true, sometimes it's if there was a variable was a negative number, it might make it not true.
So if it's a negative number, or if it were a negative exponent, then it might not be true. So you always really should check it.
You check a few things, and when we get to that point, we will talk about checking for 0, seeing if it's true for 0, and seeing if it's true for positive and negative numbers. That's usually a few things to check.
Okay.
Can't check every number that ever was, or you'll never move on from that problem.
Right. Okay, does anybody else have an I wondering or a question or something that they've done today that they'd like Mrs. Brown to talk about or cover? Nobody has an I
I
wonder.
have a question.
Yes.
So for distributing property, could you go over that one more time, because I missed that part?
Absolutely.
Absolutely. I believe we had 3n plus 1 down here.
Another one.
Pick a different one.
Is there another one?
Oh, well, we can make one up. Well, here's one with bigger numbers, but it would be the same.
Yeah, let's do one with bigger numbers.
This is one that has, it's the same type of idea, plus z, and I'm going to tell you when I write the letter z, I put that line on there so it doesn't look like a 2. So this would be another one. Whenever I have parentheses and I have a number on the outside, remember, any number outside parentheses means times.
Okay.
So one thing to look at is I can treat the inside by itself and then multiply 5 times that. Or I could think about that as 5 sets of this. So one way to think about this is to think about it's 5. I have 6 2/10 plus z, and I have 5 of them. I have 6 2/10 plus z. I'm going to write it down 5 times, because for me right now, while I'm thinking about it and I'm pondering it a little bit, the writing it down keeps my head in the math game. And I just think about what that means. So really, what does that mean in the end? If I look at it, well, I have 5 of those 6 times 2s, right? To figure that out, I would have to do 6 times 2 times 5. And so I can think about that. What is it? 30. This would be 30, and then 2/10. So that number gets a little bit bigger. That would be, would that be 31, I think? I think that's 31. I'd have to double check it. But if I multiplied 5, I have 5 of them. And over here, what do I have? How many z's do I have? I have 5 z's. So that would be the same as if I was thinking about 5 times 6.2, 6 2/10, and 5 times z, right? Because it's 5 of each piece. That's what this and is. It's 5 of this piece and 5 of that piece. What can I do, Mrs. Nelson?
I like this one because now you put the parentheses around the 5 times 6.2, put parentheses around that. No, around the whole thing. Like include the 5 too.
Okay.
Yes.
I'm gonna do it.
That's how you see it a lot of times.
So put it around here.
Just like that. Because then you go from there, and then 5 times z gets parentheses. Yes.
Right.
So you've distributed the 5. You've given the 5 to the 6.2, 5 times that, and then you've distributed and given it also to the z, the 5 times z. So in the last problem, I showed you that we eliminated the parentheses. Here what we did was we created 2 sets. because the variable was the second number, we created 2 sets of parentheses. So now we can solve that. And that's, 5z, 5 times z is z, that's z, z, z. And on that one, Mrs. Nelson would check that. I think Mrs. Brown is correct because remember 5 in my head, right? Like I'm a weird thinker. I always think of that 5 as a half. And if I were to say what's half of 62, it would be 31. So I would check that.
Love that. I had never thought of it that way.
Every time I see a 5, I think of it as a half, right? Because 0 and 5 is a 5/10, and that's half. So anyway, that's another way to do it. I know the answer wouldn't be 3.1, right? Because I have 5 times 6. So that.
You would have close to 30 anyway, because 5 times 6 is 30.
Yeah. So I'm going to repeat that one more time because Kayleen just came back in. So what I've done is I've given the 5 to the 6.2 or 6 and 2/10, and I've given the 5 to the z, creating 2 sets of parentheses because I'm multiplying 5 times 6 and 2/10 and 5 times z. So that would be the new expression, 31 plus 5z.
This sometimes what happens is instead of this being a addition sign, there's a subtraction sign. Doesn't matter. We're doing the same thing. It's just if that's subtract, I put subtract here. If it's add, like our problem, we put add here. So sometimes it's addition, sometimes it's subtraction between the two. Just bring the sign down. And so we're just thinking about it that way. Great question, Kayleen.
Thank you.
That again.
You're welcome. That's a good wondering too. And lots of times you'll see that. You'll see it where it will have that top line that's in brown, and then they'll put an equal sign, and they'll put that second group of parentheses, and they'll ask you if those two expressions are equivalent. And then you have to figure out if they are. And you can use the distributive property to see that, or you could make z equal to 1 and then solve to see.
We'll be working with those on Monday, those exact type of problems on Monday.
And these are called algebraic expressions. So we are simplifying algebraic expressions. Sometimes when we're done, we'll have a solution, which is one problem, like in the one answer, like in the top where we got 32. But sometimes when we simplify, we'll just come up with another algebraic expression. So this is called evaluating algebraic expressions.
Thank you.
You're welcome. Are there any other wonderings or questions out there?
Tomorrow you'll be practicing getting words and then putting the expressions and then substituting. But for today, this one we can work on that part tomorrow. So do come with your questions tomorrow, especially when you're giving different things. So do be looking for things you can ask us specifically about tomorrow.
Could there be more than 2 sets is one of the questions I'm getting in the chat. Could there be more than 2 sets? You mean inside of, do you mean could I have 3 in there? Absolutely. So Mrs. Brown could write a new one and we could put a 2 on the outside. And then we could put parentheses or quantity as she says. And then we could say 2. We could put another 2 plus 5x minus 3. Okay. Yeah, so then we would do the same thing. We would distribute the 2 onto the 2. So we'd have 2 times 2 in one parenthesis. And then we would add. We'd distribute the 2 onto the 5x. So 2 times 5x. And then we would distribute the 2 onto the negative 3.
The minus, yep, 2 times.
Ah, there we go.
There's 3 things in here, then there would be 3 things in here. I guess there can be 4, there can be more. If there's 2, there's 2. If there's 3, then there's 3.
That's a great question. That's a great wondering. Is that what, does that answer your question? Does that answer the question? Is that what you meant by 3 sets? And the answer is yes, so that's great. That's a great wondering.
Love it.
Very good wondering. Any other wonderings out there? Okay, well, you guys did a great job. Remember, this is called Evaluating Expressions, and you have been live with SNL. That might be our new catch line. Maybe we could have Noah write us a song. Wouldn't that be fun? And that's SNL out.